So before fall break, we talked about relations. Is that correct? One of the days of the week before fall break. I don't think it was Thursday. We did test corrections Thursday.
I believe it was one.
Tuesday. It was one day last week, right?
Yeah.
Does anyone remember what a relation is? Can you tell me?
Nope.
Look in your notes. Should be in your notes or something.
Oh, I think I remember.
What's a relation?
So basically it's like, with these two, I don't know how to explain it. Like two different, I don't know how to explain it.
Is it a connection between two variables?
I know it has something to do with two things, you gotta graph them out.
Anyone have it in their notes? What is a relation? What is a relation? It's a great question.
That I do not have the answer to.
Well, that smart person.
No one took notes last week when we did notes.
I took notes. I took notes.
I just can't look.
Now, whereabouts in those notes? That's so funny.
You guys just want me to tell you what a relation is?
No.
Okay.
Hold
A relation is a set of ordered pairs.
Oh,
That's it, right?
I found it. Right after you said it.
A relation is a set of ordered pairs.
With set notation.
Huh? Yeah, we got to use the squiggly brackets to denote a set, correct? And we also talked about different ways to represent a relation, correct?
Yes.
We represented them with a set of ordered pairs. We did a table of values. We did mappings and graphs. You guys remember that?
Yeah.
And then we talked about domain and range a little bit. What's the domain? It's my set of x values. What's my range?
Oh, set Y.
Set of y values. So my domain is my set of x values or my inputs. My range is my set of y values or my outputs. You guys somewhat remember that from last week. Today we're going to focus on functions. We're going to move on from relations and go to functions. That's what the main focus of today's lesson is going to be. Okay? So let's talk about the mail system real quick. Everyone knows how the mail system works?
No.
The mailman delivers mail. This mailbox will get a letter. This mailbox will get a letter. This mailbox will get a letter. Right? Is it okay for one mailbox to get multiple letters?
Yes.
And some mailboxes to get no letters? That's acceptable, right?
Yes.
Is it acceptable or possible for one letter to go to two different mailboxes without making a copy of that letter or without tearing it apart? Is it possible for one letter to go to two different mailboxes? No. Right? So this is what we want for a function. Keep this. What am I trying to think of? I just went blank. Keep this example in your mind when we're talking about functions. Functions do not have any repeating x values. In other words, none of your x values go to two different y values. Okay? That's what a function is. So, like we said, can I have multiple letters going to a mailbox?
Yes.
I can have multiple x values going to one y value. I just can't have the same x value going to different y values.
Yeah.
Okay? So keep that in mind, this little picture in mind when we're talking about functions. Here we go. Here's a function. A function is a relation. It's just a special type of a relation. So that's why we talked about relations first before we talked about functions, because a function is a relation. A function is a relation in which each element in the domain, my x values, my inputs, is paired with exactly one element in the range. My y values, my outputs. Does that make sense? So, in other words, a function does not repeat an x value, and the graph must pass the vertical line test, which we'll talk about here in a second. So, a function does not repeat an x value. Everyone okay with what a function is?
Nope.
If it repeats an x value, it's not a function. Simple as that. So down here, we got a couple of examples of relations. The answers are already here, but let's talk about it. Am I worried about the y values to tell if it's a function or not?
No.
Just the x values, right? So in this first relation, what are my x values?
1, 2, 4, 5.
1, 2, 4, 5. Do I have any repeating x values?
Nope.
No. So is this a function, not a function?
Function.
It's a function because none of my x values repeat. Everyone okay with that?
Yep.
Okay, next one. What are my x values?
1, 2, 1 and 2.
1, 1, 2, 2. Do I have x values repeating?
Yep.
Yes, I do. I've got two x values repeating. 1 is repeating and 2 is repeating. So is this a function? It's not a function because I have x values repeating. Any questions?
Nope.
You good with that? Pretty straightforward, pretty simple. Okay. Vertical line test was mentioned on the previous slide. Vertical line test. A graph, so we use it for graphs of relations. A graph is a function if a vertical line does not intersect the graph more than once. If a vertical line would intersect more than once, the graph is not a function. Let me draw a graph for you. Say our graph was just a line like this. Vertical line test. I always have students use their pencil to represent their vertical line. So I take my pencil and I drag it across my graph vertically. Well, my pencil's vertical. I'm dragging it horizontally though. Dragging it across my graph. And for it to be a function, I only want it to hit one point on my graph at a time as I drag it across. Okay? So here's my vertical line. I'm dragging it across my graph like this. Everyone see that? Will this vertical line ever intersect my graph more than once at any certain point? No, it'll only be intersecting at one point all the way across. Does that make sense? So would this be a function or not a function?
Function?
Function. It passes my vertical line test, so it is a function. Does that make sense? Say I had this. I'll take my vertical line, drag it across my graph. Would this be a function, not a function? Not a function. When I drag it across, at some point, it's going to hit my graph in two different spots at the same time. Does everyone see that? So that's not a function. Are we okay seeing the vertical line test? Okay, let me give you another one. Would this graph be a function or not a function?
It's a function.
Function. My two sides are angled up and out, right? So they're constantly going up and constantly going out. So if I drag my vertical line across, it's never going to hit my graph twice or more than once at the same time, is it? So that would be a function. Questions on vertical line test? Do we understand how to use it? The reason we can use this is because, like over here on this one on the right, this would be considered two x values repeating. I've got, let's say this is the ordered pair 1, 5, 1, -5. That'd be one x value going with two different y values. That's why we're able to use the vertical line test. Does that make sense?
Yeah.
Questions, comments, concerns? Okay, I'm going to hand you a piece of paper that's going to have this on it. And what I'm going to have, it's got a bunch of relations on one side, represented as tables of values, mappings, sets of ordered pairs, and graphs. And you're going to tell on the other side if it's a function or not a function. Okay? So letter A, we have 1, 2, 2, 2, 3, 2, 4, 2. Would that be a function or not a function?
It's not a function.
It'd be a function because none of my x values are repeating, are they?
Oh, no.
They're not repeating, so that one would be a function. So on the other side of the piece of paper, you would put A in the function column. Does that make sense? Okay, so let me pass that out, and you're going to work on it on your own for a little bit, and then we're going to go over it together. Okay, let's go over these real quick. We already did letter A. It's a function because none of my x values are repeating. What about letter B? 5, 4.5, 6, negative 6, 7, 8, 8, 5. Function, not a function.
Function.
Function, why?
It doesn't have any repeating it.
None of my x values are repeating. Very good. Questions on B? C.
Function. I mean, not a function.
Not a function. Here I've got repeating x values. I did forget to clarify on M. It kind of looks like that line goes vertical. It's not going to go vertical. It kind of goes up and out. So if you need to change M, change it or leave it if you think it's still the same. Same thing for O. These edges kind of go up and out, not vertical. These are hand drawn on there, so they're kind of not perfect. So if you need to change either one of those, you can go ahead and do so. But let's continue. Letter D, function, not a function. Not a function. I've got my 2's repeating in there, correct? Any questions telling if a table of values is a function or not a function? You all good with those? That first row. Okay, let's look at our mappings. You could just treat the mappings like the pieces of mail in the mailboxes. Your x values are the pieces of mail. Your y values are the mailboxes. Okay? So for letter E, is that a function or not a function? It's a function. All of my pieces of mail are going to one mailbox each. All my x values are going to one y value each. Letter F, function, not a function. Function. Once again, all my x values are only going to one y value each. Some of my y values are getting multiple x values, but that's perfectly acceptable, correct? I'm just looking at the x values, making sure none of those repeat. What about G? Function, not a function.
Not a function.
Not a function. What's my repeating x value here? 8. So not a function. And H?
Not a function.
Not a function. 1 is repeating as well as 5. Any questions deciding if a mapping is a function or not a function? We good with those? Okay, my third row, my sets of ordered pairs. I have 4, 3, 2, 5, 1, 8, 10, 4, 0, 3. Function, not a function.
Function.
Function. None of my x values are repeating, so it's a function. Questions on I? What about J? Not a function. What's my only x value there? 2. It's going to 20 million different mailboxes, isn't it? Letter K, function, not a function. Not a function. 6 is repeating as well as 5. And L, negative 2, 3, 3, 5. Function, not a function. Function. None of the x values are repeating. Questions on a set of ordered pairs to tell if it's a function or not a function? Are we good with the first 3 rows so far? Okay, M through P, what do we have to use to decide if it's a function or not a function? Vertical line test. So, letter M, is that one a function or not a function? Function. If I drag my vertical line across that graph, it's only ever going to hit one point at a time, correct? So I know it's a function. Letter N, function, not a function. Definitely not a function. At some points, it's hitting my graph 1, 2, 3, 4 times at the same time, right? When I drag my vertical line across. So I know that one's definitely not a function. Questions on N? What about O? That one is a function. Like I said, those edges are kind of going up and out at an angle. They're not vertical. So once again, if I drag my vertical line across, it's only going to hit 1 point at a time on that graph. And letter P. Raise your hand if you say function. Raise your hand if you say not a function. Only like 5 people raise their hand total. So, this is not a function. Because we're looking at this vertical line right here, correct? If I pass my vertical line across, it's hitting all my points at once. Right? So it's hitting more than 1 point at a time as I drag my vertical line across. So I know it's not a function. Any questions on that 4th row? My graphs telling if they're a function or not a function. We'll be good on those. Okay, we're going to skip Q for now. We'll come back to it. What about letter R? Function, not a function?
Not a function.
It is a function. If I drag my vertical line across, it's only going to hit 1 point at a time. Just like that. Questions on R? Okay, S. Create your own function. Raise your hand if you can tell me your function you created. Yes?
I did a table value thing. The x values are 1, 2, 3, and 4. And the y values are 2, 3, 4, and 5. Just carrying it from there.
Everyone agree that that's a function?
Yep.
I agree as well. Good job. None of my x values repeat. It's a function. Raise your hand if you can tell me your non-function you created.
Okay, so I did like what the third line did.
You did what?
What the third line did. The middle.
Oh, the set of ordered pairs?
Yeah. I did 1, 2, 1, 3, 1, 4, and 1, 5.
Everyone agree that that's not a function? I agree as well. My x values are repeating, so I know it's not a function. Questions on how to create your own function or not a function? You could have created a table of values for either one of them. You could have created a mapping for either one. You could have created a set of ordered pairs for either one or a graph for either one. Okay? Now let's talk about Q. Raise your hand if you said Q was a function. Raise your hand if you said Q was not a function. There's like 5 people raising their hand again. Raise your hand if you didn't answer it because you didn't know what it was. That's what I figured. Let's talk about it real quick. So there's a couple of ways you could approach this one. One way is to create a table of values. An input-output table, which is essentially a table of values. You start plugging in numbers for X, and you get numbers for Y out of it. So that gives you ordered pairs to graph this relation. Does anyone know what this graph turns out to be?
Bad graph.
No, it's a good graph. It just turns out to be a straight line similar to a letter R. So would that be a function or not a function? Function. Or you could have graphed it. Some of you guys may remember this from pre-algebra or algebra 1, how to graph this using the slope and the y-intercept. What's my y-intercept in this case? 3. 3 is my y-intercept, so I'd graph that on my graph on the y-axis, put a point at 3. What's my slope in this case?
2 over 1.
2 over 1. Rise over run. From my y-intercept, I'd go up 2, right 1, put a point. Up 2, right 1, put a point. I can go down 2, left 1, put a point. Down 2, left 1, put a point. Once again, creates a line similar to letter R. You guys remember that a little bit? Some of you, maybe. Some of you, maybe not. Well, lucky for you guys, we will cover that more in depth later in this chapter.
Yeah.
There we go. We'll talk about slope dude and all that good stuff.
Slope
So-
dude was a
That one is a function because it creates a straight line. None of the x values repeat. Okay? Any questions? Here's our answers once again. Functions were A, B, E, F, I, L, M, O, Q, R, S. Not a function, C, D, G, H, J, K, N, P, T. Any questions on any of those? We okay? So we're good identifying functions and non-functions. Can I move on? Okay. Domain and range. What's the domain? It's my set of all x values, aka my inputs. What's my range? It's my set of all my y values, aka my outputs. You guys remember that from when we talked about relations? Now, when we were talking about relations, to state the domain, we just listed all our x values because they were just points on a graph, right? It wasn't anything like we saw over here, where they're connected with lines or curves, correct? Well, let's talk about finding the domain and range of graphs with curves and lines and stuff like that. I want to find the domain and range of this graph right here. First off, is this a function or not a function?
function.
It's a function. It passes the vertical line test, right? We've got to find the domain. Like I said, we're used to just seeing a graph with a bunch of ordered pairs. And I just list the x values of the ordered pairs, right? Well, on this curve, everywhere on this curve represents an ordered pair. There's an ordered pair here, 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 here. Between these 2 points, between these 2 points, between these 2 points. There's an infinite number of ordered pairs on this curve. So it would literally take me forever to list every single x value. So there's an infinite number of them. Negative 3.99999999999 is an x value. Negative 2.5794317219872 is an x value. It would literally take me forever to list every single x value. So I've got to come up with a compound inequality to represent every single x value. Like I said, I've got to come up with a compound inequality that represents all those x values without me having to list them all. Okay? So, set notation. My domain is the set of all real numbers x such that, go ahead and write that down. You got to write it down like this. My domain is the set of all real numbers x such that, not quite, it's going to be compound inequality. What's my smallest x value? Remember, x, the x-axis is the horizontal, so I'm looking at my numbers horizontally here. What's my smallest x value? What's the farthest left my graph goes? Negative 4. Does everyone see that? This is as far left as my graph goes. Correct? So negative 4. Is negative 4 included on my graph or is it not included? Why is it included?
Close dot.
It's got a closed dot. Very good. So my inequality symbol here is going to have a line under it. Correct? So, are my x values that are being represented by this graph, are they greater than negative 4 or less than negative 4? Greater. Remember, we read it from the variable's perspective. X is greater than or equal to negative 4. Okay? What's my biggest x value? 2. Does everyone see that? The farthest right that my graph goes is 2. Is 2 included or not included? Included. It's got a closed dot. So it's going to have a line under it. I've got 2 over here. Are the x values that are represented less than 2 or greater than 2? Less than 2, so it's less than or equal to. There is my domain of this graph. It's all the values that are between, all the x values that are between negative 4 and 2. Correct? Where negative 4 is included and 2 is included. So it's all my x values that are greater than or equal to negative 4 and less than or equal to 2 at the same time. This is an and compound inequality. Does everyone see that?
Yep.
Any questions on my domain here? Now we got to find the range. Range equals the set of all real numbers y such that we're dealing with y instead of x now. So instead of looking horizontally, I'm now looking vertically. So what's my smallest y value? What's the lowest the graph goes on the graph? 2. 1, 2, right? Does it go lower than this?
Oh,
No, it does not. There's my lowest y value. Is 2 included or not included? Included. It's touching 2, is it not? It's touching 2, so less than or equal to y. Well, y is greater than or equal to 2, correct? Because it's everything greater than 2. Okay, what's my biggest y value? Where's the highest it goes? 6. Does everyone see that? Is 6 included or not included? It's included. So is it going to be less than or equal to or greater than or equal to? Less than. And there's my range. It's all the y values that are greater than or equal to 2 and less than or equal to 6. And that covers all my y values. Does that make sense?
Yep.
There's my domain and range. Questions there? Huh?
That's what messed me up last year.
Yeah.
I didn't understand how to do this.
Y'all were probably really confused when you first saw it, but does that make a little bit of sense now? Okay, let's do another example. Find the domain and range of this graph. Is this a function or not a function? Function. It's only going to hit one point on my graph at a time when I pass my vertical line across. This is a function. So my domain equals the set of all real numbers x such that... Does anyone want to take a stab at the inequality? Yes.
You want me to do it?
Yep.
So, 1. Yeah, no. So, set of all real numbers x such that 1 is left.
Talking about x values here, left and right,
Yeah. So.
horizontally.
Oh, so 2.
2.
Sorry, my bad. 2 is less than x.
Less than x.
Less than 6. No, less than 7.
Does everyone agree with that for the domain? Or is there any disagreements? I agree with that. It's all the values that are between 2 and 7. Because remember, we're looking horizontally. Farthest left it goes is 2. Farthest right it goes is 7. 2 and 7 are not included in my domain, correct? Why are they not included? They got open dots, right? So they go all the way to 2, but 2 is not included. It doesn't go. It goes all the way to the numbers up to 2, but not 2 itself. And all the numbers up to 7, but not 7 itself. So it's all my values that are greater than 2 and less than 7 at the same time. Does that make sense for my domain? Okay. My range now. My range is the set of all real numbers y such that, raise your hand if you'd like to take a guess at this one.
1 is less than y. 6 is greater than y.
Like that?
Yeah. I don't know how to explain that.
Everyone agree with that, or is there any disagreements?
I agree with that.
I agree with that. We're looking vertically this time. The lowest my graph goes is 1. Everyone agree with that? And the highest it goes is 6. So, set of all real numbers y such that y is greater than 1 and y is less than 6 at the same time. Right? All the values between 1 and 6, where 1 and 6 are not included. Everyone understand domain and range a little better this way? Another example. This is what we are used to seeing from our relations, correct? Just a graph with a bunch of points. Do I have an infinite number of x values and an infinite number of y values here?
No.
No, because I don't have any lines or curves connecting my points. On these, I have infinite numbers because everywhere on that line represents an ordered pair. Everywhere on that curve. Everywhere on this curve represents an ordered pair. Here, they're not connected, so I just have a set number of x values and a set number of y values. So for my domain is a set of all real numbers x such that x equals, I'm just going to list my x values here. What's the x value of this ordered pair? Negative 2. And this one? Negative 2. Do I have to list negative 2 twice? No. What's the x value of this ordered pair? 0. What about this ordered pair? 1. And this ordered pair? 3. Everyone okay finding domain that way? My range is a set of all real numbers y such that y equals, and I'm just going to list my y values now. What's the y value of this ordered pair? Negative 3. What about of this ordered pair? 1. And this one? 1. Do I have to list it twice? Nope. What about of this ordered pair? What? 3. And this ordered pair? 4. There's my domain and range of this relation. Is this relation a function or not a function?
Do you want us to list the smaller values first?
You don't have to, no. Just as long as you have them all there. It's not a function. I got repeating x values, don't I? It does not pass the vertical line test. Oh, it hits these 2 points at the same time. Okay? Questions on domain and range? You guys ready for your assignment?
Yes.
You'll get your assignment tomorrow in class. No assignment tonight. Okay? We got 3 minutes left. The piece of paper I gave you, the function, not function activity, that just goes with your notes. That wasn't any homework, that was just your notes. Like I said, we'll do the assignment tomorrow in class. Are there any questions about the recording before I stop the recording?